Okay. Hey everybody. In this video, I'd like to talk to you a little bit about integer arithmetic in YASM assembly on an x86-64 system. So what am I talking about? Well, integer arithmetic. I want to take integers and I want to add them together, multiply them together, whatever. This video is mostly going to focus on signed integer multiplication, but I'm going to briefly skim through unsigned integer multiplication and also addition. And anyway, so for starters, let me go up to the top of this book here that I've got. I'm going to show you pages from a book that I really love. I mention it in a lot of my other videos. It's called x86-64 Assembly Language Programming with Ubuntu, and it is written by a brilliant professor who is just interested in everyone learning. This is an open source book. You can get yourself a copy for free. Just look that title and name up. You can find his website. You can grab a copy. And you too can become an assembly expert just by reading this book. Honestly, this book has everything that you really need to really level yourself up well beyond, I think, the master's level of college. Probably not as much as the person who wrote the book, but you never know. Anyway, let me collapse all that. I want to go down to section 7 here. And it's called Instruction Set Overview. So here you can have like an overview of like all different types of instructions, but I'm going to focus on the integer arithmetic instructions. So I'm going to go to 7.5. Notice how the first section in here is addition. I'm not going to give you an addition example because it's just too easy. You pretty much just use the add instruction. And then you have a source and destination operand, actually dest comma source. In x86 YASM assembly, it's pretty much the destination is the first operand. So that's kind of implied usually when you have just like a two-operand instruction. Now we could add using three operands, and the first one would be the destination, and then the other two would be the sources. But I'm going to scroll down past that to the integer multiplication section. 7.5.3, at least as of the version that I'm using. Unsigned multiplication is a little tricky. You kind of have to decide what data size you're going to go with, and then you use the instruction. And then you end up with some answers that are spread across multiple registers. I'm going to eventually make other videos where I can talk to you about how to manipulate multiple registers, or at least know that they're there, like EDX and EAX. Those are definitely not 64-bit registers. So if we were clever, we could just sort of manipulate those so that the whole answer showed up on one single 64-bit register if we wanted to. But just know you can multiply unsigned integers. It's a little bit more complicated than signed integers. So in this video, I'm just going to talk about signed integers. Let's see. So signed integer multiplication. So in order, that's section 7.5.3.2. If you want to multiply two integers and they're signed, meaning they have a plus or a minus sign, meaning they're designated as either positive or negative rather than not designated at all, which would usually just mean positive, you can use IMUL as an instruction, and well, you can just provide, one operand, two operands, or three operands. Let's do the three-operand version first because that's probably the easiest to understand right off the bat. So we would take a number that's sitting in a register, and then we would multiply it by some immediate. Notice how IMM is sitting here. The result of multiplying a register by some number would just go into the destination operand. So that means you'd put a register here, you'd put a register here, you'd put a register here, you'd put an immediate here. In one instruction, then you'd have some sort of an answer on what these two numbers were multiplied against each other. If you use the two-operand version, then you're allowed to specify a register for the destination and a register for the source. But notice how the destination gets overwritten here. So, it's going to multiply this number by this number and then just store the result in the first register. So you will kind of overwrite something. It's maybe more convenient for you to use the three-operand version if you only want to multiply by an immediate, but, Anyway, and then for the, let's see, I think you can square a number just by specifying its source here. It'll multiply a number by itself. And then let me just go down a little bit. I'm starting to get lost in this book. Let me go down a little bit. Oh, I guess that's all we really had to say. Okay, so let me show you a sample program that I prepared so that we can multiply. Okay, sample program. I think I need to rehearse myself a little bit more before I record videos. Anyway, I've got this empty source code file here. Keep in mind that, well, I don't need that. Keep in mind that I have a sample program here already. I'm not going to really focus on the contents of it because this is not, what did I do wrong here? Main and math. Is main empty? No. Where's my makefile? Oh, I forgot to open it. This is not a video about makefiles or hybrid programs or anything like that. That's covered in my other videos. So I'm just going to say, hey, I've got a makefile that compiles my assembly source code. And then I've got a driver C source code file, which its entire job is just to have the main entry point because I'm linking against the GCC libraries. And then its job is just to call on a math function which sits in my assembly module. So now my assembly module is blank. What should we do? First, I'm going to copy paste from my solution here. Just a bunch of strings. So I've got a data section. Then I'm going to get set up. This is not a video about the basics of assembly programming. See my other videos. But for now, I'm just going to say, well, I've got a bunch of strings. I'm going to say the result of multiplying immediates is this. The result of multiplying globals is that. We're just going to do a couple of multiplications and then see the result. Okay, so then a couple more variables before we're finished is I'm going to now say that we have a system call for system write, which is not what this video is about. See my other videos for system calls. Same thing for file descriptors. It's there. I'm not going to explain it too much. I'm just going to print a standard output. And then from this program, I'm going to return just an integer for whatever reason. I'm just saving it as a variable. And then we want to multiply some integers. So I'm storing two integers in the global section, still inside of the .data section. So these are going to be global variables. They're going to both be quad words. So I can load up into quad registers or quad word registers. And now I'm ready to start my text section. So the first thing that I'm going to do is just, say, here we go. This is the text section. That's where all of our instructions go. And then I'm going to name two external symbols. Don't worry about these symbols. They are not the point of this video, but I have a little library that I wrote that helps me print and take input from the user. I'm going to print an integer. I'm going to take an input from the user. So don't worry about that. That's not the point of this video. Really, I just want to make it so that when I demo, I can just easily type in an integer and then just print it to the user. So let's look at our main entry point here. Remember, the driver calls on a function called math. So I'm just going to make an entry point called math, mark it as global so the driver can call on it. And then I'm going to, whoops, why did I put load here? I'm going to say do it right there. Let's do it. I'm just going to call on a function I wrote called multiply test. Kind of pointless if you think about the fact that there's like no code in the main function here. But that's the way I like to do it. When we're done, we're just going to return our return value that's already been defined. And so now I'm ready to start setting up our multiply test. Maybe I'll just copy paste the header here and I'll say, this is going to be a label called multiply test because I'm going to call on it and try to use it like a function. I'm going to put a return instruction at the very end. So now it really is a function. I'm going to use these registers. So I'm going to use R12, R13, R14, and R15 to hold temporary immediates and globals just for multiplication. So I'm basically going to be using the registers to hold my data. And because I'm going to use all of those registers, remember you have to respect the ABI. So that means we have to have a push-pop pair on all of those registers because they're designated as callee-saved. If anyone calls on your functions and you're not respecting the ABI, then you're probably about to crash the program in some way. Or even if you are the only person who writes any code that your code calls on or gets called from, you're probably still going to regret not respecting the ABI eventually when you forget what's going on. Anyway, so let's multiply some immediates. First thing I'm going to do here is I'm going to say, let's take 233 and move it into R12, because that's where we're going to hold some temporary immediates. And then the number 256, put that into R13. And then I'm going to use the IMUL instruction to just multiply those two values together. Because this is the two-operand version of that instruction, the result will also be stored in R12. So that means 233 will be erased from R12 and the answer will be in R12. So then I'm going to prefix the results for the immediate because I like my programs to be pretty. I'm not just going to print the numbers and then hope I can remember which number comes first. That's usually a huge mistake if you're trying to debug something even a little bit complicated. So I'm going to print my string, which I'm calling the immediate prefix. And if you look back up at the top right here, it's just going to say the result of multiplying immediates is, and then it's going to put 3 asterisks, and then I'm going to print the actual result. And then the suffix is just going to be 3 more asterisks. So we should basically see the results surrounded by asterisks. So I'm doing that. And then I'm going to use my library to call a special printing function so that I can just print the result. So R12 is where the result of the multiplication is. I'm going to give that as the first argument, which is the RDI register, if we're talking about integers. And then I'm just going to call my function that'll print for me. And then I'm going to print the suffix. So the suffix is just that other string we talked about, just it trails with asterisks. I'm then going to call on a custom function called crlf. All that's going to do is just print a new line. I don't know why I do that. I could easily put that into the string, but it's more fun to call functions. Although to be fair, every time you call a function, you are jumping to an instruction elsewhere. And so the CPU does pay a penalty. So if you're trying to write programs for high performance, you might not want to do that. Anyway, so this is pretty fast because I'm really just using an immediate and then I'm loading it into a register. I'm not actually touching global memory. So this should be a lightning fast multiplication operation. Let's see if this actually works. If I didn't screw this up. Whoops, what did I do there? Oh no. I have too many videos now. Gosh, okay. Clear and make run. Oh, what have I done? Undefined symbols, CRLF. Did I forget? Oh, I forgot to copy paste my CRLF function. Yeah, so again, don't worry about CRLF. All I'm doing is just printing a new line, carriage return. It's just, you know. This is from another example where I was trying to prove to somebody you need to preserve registers in respect to ABI, so don't even worry about that. Let me get rid of that. You know what? I'm going to leave it as is because if I take that out, then I have to take the time to remove the push pop pair because there's no point at that of doing that if I'm not messing with those registers. Forget about that. It's not part of this video. Anyway, I'm going to run the program again, and you can see that the result of multiplying immediates is, and so this whole string right here was my prefix. So again, not really the point of this video. And then this is the result of multiplying those two different numbers, and then the suffix with the stars after. So let me just prove this to you. Where's the dang calculator? Oh man. I need to work on my icons. I just did something screwy and I have like no good icons anymore on this virtual machine. So we were going to multiply 233 by, by, what was it? 256. Result is 59648, and you can see that's on the screen, 59648. So we have successfully multiplied signed integers. And since they're signed, we could multiply negative numbers if we wanted to. I'm not going to here, but you can. Now the next thing let's try is, let's multiply stuff sitting in global memory. Okay, so I'm just going to copy this. Where the heck is it? Okay, so remember at the top we made two global integers. We said integer a is equal to 233 and then 256. Those were the same numbers that we just multiplied, so we should probably get the same result if we're lucky. So I'm saying I'm going to move both of these into registers. So I'm going to move A into R14 and I'm going to move B into R15 just to prove to you that we can. And then I'm going to multiply them with the same instruction we did before. The result is going to go into R14. So let's see. I'm going to print the prefix real fast here. Same kind of concept that we talked about before. There's just going to be a prefix before the result. And then I'm actually going to print the result with this line right here, or these lines. I'm just going to print R14, which is holding the result at this point. And hey, we can trust that R14 wasn't killed by the system call because the system call respects the ABI. And then I'm going to print my suffix right here and then a CRLF. And that's basically the idea. Let's just double check here that we get the same result twice. Make run. Notice how it prints the same result twice, once with globals, once with immediates. So if you were wondering before this video how to multiply immediates or how to multiply globals, well, there you go. Just put them into registers first and then call IMUL. Pretty fast. Let's just do one other thing for fun. I'm going to, let's see, add one number to R14, so to the result of the multiplication. And then I'm going to add 5 to it, just to prove to you that we can increase an integer by 1, and we can also just sort of like add two integers together. So before we print it, before we do the prefix, extra stuff just for fun. So here I'm going to increase R14, and I'm going to say that it is a Q word. I guess that's implied already because R14 is considered a 64-bit register. But if we wanted to increase, I don't know, just for the sake of argument, if we wanted to like increase this right here, let me just show you real fast how we do it. We would say increase Q word and then name the integer in global memory. So in global memory, the system doesn't really know by default if it's a 1-byte integer, a 2-byte integer, or 4 or 8. So you just have to specify the data size so it knows which integers to look at when it's considering what the original value is and how to overflow and when to overflow. But, you know, just for fun, I'm putting that in here. So it's going to increase the result by 1, and then it's going to increase the result by 5, and it's going to do that using the addition instruction. So we're going to add R14 with 5. We can put an immediate there, and the result is going to be stored in R14. So basically R14 is equal to R14 plus 5. And so overall, when we add those two things in there, the second result should now be about 6 higher than the first result. So if you kind of look at this right here, we have 648, and then we have 644, which is 6 numbers higher than the original result. So these are the basics of integer arithmetic with signed multiplication and addition. I think that's all I really wanted to show you. Yeah, okay. So I hope you learned a little bit of stuff from this video. I hope you had a little bit of fun. Come back, I'll see you in the next video, and happy coding. Hey everybody, thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community, so we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness, which is coming for us all.